Hello there, I am Ümit Alkuş. In this video, we will solve one problem in chapter 11. You hit a Russian billiard ball whose radius is capital R as 34 mm with a stick as shown in the figure. The rotational inertia of the ball around its center is I equals 2 over 5 m times r squared, where m is its mass. If the ball is to start the roll without skidding from the outset, what must be the value of d? You can ignore the frictional force. First of all, let us investigate the rolling without skidding condition. Assume that the Russian billiard ball goes from position 1 to position 2 by rolling without skidding. Here there is a name for the contact point between the ball and the surface as instantaneous axis of rotation. In this contact point, the velocity of the ball is 0. If change in the angle is theta, then distance d is equal to the arc length, which is r times theta. The magnitude of the velocity of the center of mass is found by the first time derivative of the arc length, where s is r times theta. The derivative of product r times theta is dr over dt times theta plus r times d theta over dt. Here radius r doesn't change, so dr over dt is 0. Here d theta over dt, omega, is the angular speed with respect to the rotation axis passing through the center of mass. As a result, the magnitude of the velocity of the center of mass becomes r times omega. Now, the magnitude of the acceleration of the center of mass is found by the first time derivative of the magnitude of the velocity of the center of mass. That is dv_com over dt. Here v_com is r times omega, so the first time derivative of product r times omega is dr over dt times omega plus r times d omega over dt. dr over dt is 0, and d omega over dt is the angular acceleration denoted by alpha according to the rotation axis passing through the center of mass. Therefore, the magnitude of the acceleration of the center of mass is obtained as r times alpha. Anyway, the equation of linear motion by the help of the Newton's second law of F net equals m times a, our problem can be simplified as if force F acts on the center of mass of the billiard ball. Since the acceleration of the center of mass is a_com, we have the Newton's second law as F equals m times a_com. Here a_com is r times alpha, so F is m times r times alpha. Additionally, the equation of rotational motion can be written as net torque according to the center of mass equals rotational inertia of the ball around its center times the angular acceleration. Since I_com is 2 over 5 times m times r squared, we have the net torque as 2 over 5 times m times r squared times alpha. The definition of torque measured with respect to the rotation axis passing through point O is RO cross F, where RO is measured from point O. The magnitude of the torque is found by RO times F times sin theta. According to the figure, F times sin theta is the component of the force perpendicular to the line of extension of position RO. So tau becomes R of times F perpendicular. Also, tau is Rho times sin theta times F, where Rho times sin theta is the component of Rho perpendicular to the line of extension of force F. So, tau becomes Rho perpendicular times force F. Anyway, according to our problem, if we extend force F, which is called the line of action, the component of position vector capital R perpendicular to the line of action becomes R perpendicular. So, tau becomes R perpendicular times F. From the figure, R perpendicular is D. So, tau becomes D times F. From the equation of linear motion, F equals m times r times alpha. And from the equation of rotational motion, tau equals I times alpha, which is equal to 2 over 5 times m times r squared alpha. So we can write d times m times r times alpha equals 2 over 5 times m times r squared times alpha. After some cancellations, d is obtained as 2 over 5 r. We put the value of r into this equation. Therefore, d is found to be 13.6 meters. If you strike the ball at a point higher than this value with respect to the middle level, it will spin forward and skid at the same time. Similarly, striking the ball at a point lower than this value from the middle level will cause the ball to skid and to spin backward. Okay, this is the end of the discussion of this problem. Thank you for your attention. See you in the next video.